All right, so I quickly created a program for you inside of Ruby, just to basically select one person at random every single day for me to find your code and to essentially tear it apart in front of other people. And it's good. Mostly, it's good for you to see like what more senior developers are going to be looking for on your code. Like, what are some things that are common? Maybe you can, maybe you can be safe. Maybe you can learn what it is to write like really, really good code, like clean code. Maybe the spacing is off for right now and things of that nature. So I have two ways of finding all the different. I have all the students here. I'm just going to choose a random one. So the first one is like the way that I would probably write the code. There are a lot of built-in methods into Ruby that kind of make mad. Like there's a lot of Ruby magic. There's a lot of things that Ruby just kind of does for you that you may or may not realize, like just more or less just happens. Like I have a random .sample method. As long as I have an array full of people, I can just do .sample and it chooses a random thing. So those are one of those, like the other day we were trying to find if we just have John and Sean from the other day, and we had to find a random number between the length of that array, and then we had to choose, get that random number and then put it inside, access that particular random number for students. So there's multiple ways of doing this particular problem. This is the way that I would probably do it. So I'm doing students. This %W is a Ruby specific method, which basically takes all the contents inside of here, as long as it's separated by spaces, and turns these all into strings within a giant array. And I can just do students.sample. An even easier way, since I'm only using this variable one time and I'm just returning a random person out, I could probably just do this. So there's going to be something called method chaining, which we'll talk about in either today or tomorrow. The other option of what I can do here is I can list out all the students inside of an array. I can choose a random number just like we were doing the other day. So I'm just going to choose a random number between 0 and the length of this particular array. The double dots in the middle means that it's inclusive of both the first number and the last number. So I just grab a random number between 0 and the length of this array, probably -1. And then I'm just going to do students at that random number. So it's up to you. There are always multiple ways to solve one particular problem. There's not one right way. There's just many different ways. So for us, I'm going to go back to this first one here, and we will choose a problem at random. So which problem do people want me to go over and to review from yesterday? What did we have yesterday? Let's take a look. Remote, hold on for a quick second. I'm going to change the network. All right, and we're back. So let's go back to week 1. Yesterday was Wednesday. Which one of these challenges would you like to see review for?
Roman numerals.
Roman numerals, all right. So we have a few pull requests, I'm sure. We got 4 over here. Makes sense. Let's just run this program and see who is our lucky winner for today. So Jackie is our lucky winner for today.
Also, the array does not specify which John is which.
Okay, we're going to take a look at Jackie. All right, so we have a partially working solution, so that's fine. We'll take a look and see what we can do. I'm going to use a Git workflow, and since this is a branch that exists on GitHub, I can check out to that branch really quickly. So first things first, I'm going to clone it down, and we'll take a look. I'm going to clone this, and the act of cloning is going to be git clone and then the link. So any git command that you do is prepended with this git as a first word. Yep, Sean.
Like, is there any sort of like, you can kill your branches, like you can delete the branches and such. Do people ever do that, or do they just, once they've uploaded whatever branch they're working on, they just leave it?
Sure.
What's the like best practice for that?
Sure. So the question was for the recording and for remote. You can open as, the question was, can you delete branches? And the answer is yes. Do people delete branches? And the answer is also yes. Because at one point, if, let's say you're working on, like when I was working at Groupon, I was working for customer service. On the customer service app, I had probably 15, 20 branches. And at one point when I just run, I'll show you in just a second. First, I'm going to clone it down. I'm going to go inside of Roman numerals. Right now, when I run git branch, it just shows all the branches that I have out on my machine. When you start seeing a full page of like git branches, you're going to start to want to delete them. Other people just kind of left them there forever. It's up to you.
That will only delete the branches
On your machine, it will not delete it from.
I'm saying that there'll always be a jillion branches for every file.
Yes, that's correct. Yeah. So I'm going to check out a new branch using git checkout. Actually, no. I'm not going to check out a new branch because Jackie's one already exists. So we'll go here, go back to Jackie's, and I can, instead of just copying and pasting the code from the top, I can just go grab her branch name and go git checkout without a dash b, Jackie and John. If this branch exists, I will switch to it. So I'll switch to a new branch called Jackie and John, open everything up in Sublime, and we will take a look at what we've got here. I believe this was Ruby, so JavaScript. All right, so yesterday's thing was in Ruby, so I'm going to choose somebody else at random. So let's cd out one level. Ruby, student picker, James. Okay. All right, let's see. James, do you have a thing from yesterday?
No, we did not. We did not get that one.
All right, I'm just going to choose Michael Dorsey for now. All right, Michael branch. So we will cd into Roman numerals. We're on Jackie and John. I'm going to check out to a branch that exists called Michael branch. This turns from Jackie and John's version of Roman numerals there to Roman numerals to Michael's branch. So let's take a look at what we got here. So I'm going to be as harsh as I possibly can just to make sure that we have everything looking well. First things first that I notice are double quotes. Inside of Ruby specifically, if you're going to interpolate, do double quotes, otherwise do single quotes. There's no performance difference, but when other developers read your code, they know right away, like, oh, I'm not interpolating anything. I can relax a little bit. It's just a string. All right, let's take a look. So we have M to 1,000, all of this stuff. All right, that's kind of what we expect. So I have a return numeral. Okay. I have a tester equals 0. I see that I'm using, I can highlight tester and press Command D a bunch of times and see that this particular variable is not really used anywhere. So I'd probably get rid of this. Def2 Roman, it takes in one number. Roman hash, each do Roman numerals. So you're iterating over each individual key value pair, starting from the top and going down to the bottom. The get occurrence is num divided by a Roman numeral of 1. What is Roman numeral of 1?
So what we found is that when we do Roman hash dot each do, and what we did was the Roman numeral variable. When we print those out, it actually just prints out a bunch of arrays with each individual one. So we just figured whatever that particular one is at that time, we want to do Roman numeral 1, which would be 1,000 if we're on them.
That makes sense to me. So the issue that Michael and John were finding yesterday is that when you iterate over each key value pair, Roman numeral is actually a hash, an array with two things inside of it. The first thing is the key, and the second thing is the value, right? All right, I'm not really pleased with just saying that and people not seeing it, so I'm going to show you a quick library. There's a library called pry. And remember, a library is thousands of lines of code that someone else wrote ahead of time to make your life easier. So I'm going to require it at the top. Requiring at the top means I'm going to bring in that external library into my particular file here. And then, in order to put a stopping point at any particular point in the code, I'm just going to put a binding.pry here on line 22. So the code's going to execute, go through everything, go through everything, go through everything, and then it's going to stop exactly here at line 22 so that we can take a look at everything else that we have inside of there. Yes?
Two things. I mean, that means you're going to have a gem, right?
What's that? Yes, you're going to have to install the gem.
anything is, it's essentially the same thing as debugging, right?
Yeah, it is exactly the same thing as debugging. Yeah. So let's run this. So we list out everything. Let's go inside of the Ruby folder, list out everything. We're going to run Ruby Roman numerals.rb. So I'm running through the code, and it stops here at line 22, just like we said. Now, the good part about stopping right here is I can evaluate every single thing, and since I'm within a loop at this point, I can stop and know exactly where I'm at. So I can take a look at things like, what's num? Okay, I passed in 9. What's Roman hash look like? Okay, it's this giant thing. What's return numeral look like? It's just an empty string. So let's take a look at what, so we said Roman hash is this giant thing. We're iterating over it using each. And the first time through, we're saving this first key value pair as Roman numeral. Let's see what we get. That's what they meant. So I see that Roman numeral is not a key value pair, but it's actually an array with the first thing being the key and the last thing being the value. I could do this and then finish up here. But there's actually an easier way of doing it. So there's actually, when you iterate over a hash, you can get access to the key and the value. So I can each do Roman numeral, that's the letter over here. I'm just going to call it Roman letter because that's how I think. And then just number. So when I iterate each time, I have access to individually the letter and the number. That's probably what I would do here. But going back to your thing, because we're going to use this. So what is get occurrence? Like, so when we think about the naming of variables, we want to make sure that the variables are named in such a way that we can just look at it and know immediately what it is. I have no idea what get occurrence is. I can guess, but it's like, because it's kind of ambiguous, what were you aiming to try to do here?
So really, we were just aiming for. So, well, we named the variable get occurrence, and we just set that equal to whatever, I guess, occurrence or whatever it is.
It's just the amount of times that Roman numeral is going to occur. Right. It would probably make more sense to get occurrences, just so that it would be the amount of times that Roman numeral occurs within the within num.
Okay. Does anybody else know what get occurrence is at this particular point? So it makes sense in your head, but I think everyone kind of caught on to that first part that you said. It's the number of times it's divisible, like evenly divisible, right? So I might just actually name this even number of times evenly divisible. Obviously, for right now, like, these are very ugly and long, like, variable names. But for right now, like, I just want to make sure that everyone is absolutely on the exact same page. Number of times evenly divisible. So if I have the number 9, 9 divided by 1,000 is 0, all the way down to this particular point where it's the number of times it's evenly divisible is 1. So at that point, I'm going to subtract the number of times it's evenly divisible times that particular number. Okay? And then while the number of times evenly divisible is greater than 0, you don't need to do. Return numeral plus that, and then minus equal 1. Oh, I see. So you're basically saying, let's say we had the number 33. Or, yeah, sure, we can do 44. No, let's do 33. You're saying, actually, let's just stop here. Let's put a bunch of binding pries and see exactly what we get. So I'm going to copy this. Let's exit out real quick with a bang. I'm going to run it one more time. And I have 4 different stopping points. So as of right now, return numeral has nothing inside of it. Roman numeral at this particular point is m with 1,000. When I exit here, I'm going to execute this next line and then stop the next time it says it has a binding pry. So I'm here, I'm stuck at line number 24, 24, and I'm going to see the number of times that this is evenly divisible. Number at this particular point is 33. Roman numeral at the index of 1 is currently 1,000. So the number of times evenly divisible is 0. Okay? So at this point, I'm going to exit here and let this next line of code execute and stop at line 26. All right. So let's see, what is the number of times evenly divisible? Roman numeral at 1. When I do not number minus that 0 times 1,000, I should still remain with 33. And then I think that's it. I think at this point, this particular bit of code is not going to hit because the number of times evenly divisible, since it's equal to 0, it's not greater than 0. So it goes through the next time. So I exit here. And then at this particular point, Roman numeral is 900. And I'm just going to keep going through over and over again. Oh no, this sucks. What is Roman numeral at this point? 500. Okay, 1, 2, 3. 400. 100. Let's take a look at where we are. 90. We're not there yet. We're almost there. 50. Okay, here we go. 1, 2, 3. Roman numeral at this particular point is 10. Return numeral is nothing. And the number is still 33. All right. At this particular point, when I take a look at what number is, what Roman numeral of 1 is, I get 10. So 33 divided by 10 gives you 3.3, but inside of computers, it doesn't have any decimals. So it's just 3. So I'm going to exit this first time. And you can kind of see the number of times evenly divisible gives me 3. So I'm just calculating the number of times that 10 goes into 33 evenly. I'm going to exit one more time. And you're going to see that the number is now 3 because I've subtracted the number of times evenly divisible times that particular Roman numeral. So this is 3 times 10, and then the remainder is going to give me 3. So at this point, the number of times evenly divisible is greater than 3. I'm going to add things to the return numeral, and then, yeah, let's just subtract until it equals 0. Okay, I understand what you're going here. So when I exit out of this point, I'm going to go through the loop one last time. Return numeral is XXX, and then our current remaining number is going to be 3. Going through the same thing one more time. 2, 3. Uh-oh, I think I'm stuck in a loop somewhere. There we go. Let's see if this works. Let's just run it. I forgot to put a P in the front to print. 33, cool. All right, let's fix up a few things. Overall, I like the way that it looks. It's fairly clean. Now the things are named pretty well, but you can kind of see Roman numeral 1 is used twice, and you don't know what Roman numeral 1 actually is. So I would do an each with the key and the value, so the Roman letter, perhaps, and then the actual number, Arabic number. So the number of times evenly divisible is going to be, instead of Roman numeral 1, is the actual Arabic number. Get rid of this, get rid of this. And then the Roman letter itself is that Roman numeral 0. And I think that's pretty good. I think that's about all I would do here. We still get 33, I hope. And everything looks good. I might do something with this while loop, but I don't want to beat a dead horse. This one works. Overall, it looks pretty clean, with the exception of having double quotes instead of singles. With this each loop is inside of a hash, you have access to both the key and the value pair. Real quick, did everyone reach out to their mentors?
Yes.
Is everyone scheduled to meet with? Who's your mentor?
Trevor. He said he's not available until next week.
Okay, that's fine. As long as you reached out to.
Same thing Don said.
Don said next week.
Said possibly this weekend or next week.
Cool. Sounds good.
I haven't received. I haven't heard back.
You haven't heard back?
I mean, I just hit him up like late 2 nights ago. So.
Okay. You had Toby?
Yeah.
All right. What I want to do today is a giant review of everything. And let me stop the recording here and then restart it, just so we have clean recordings.